All right, the first important piece of information is that Jack has turned on the light.
Yes.
All right,
Yes.
Micah, it's been done. I know it's hard to believe.
Oh my gosh.
What?
I need a microphone. You should get two. I might be
Yes, we should hug them all.
All right, we have several suggestions from the crowd. Leon doesn't sleep. Thank you very much. Look how attentive he looks. He's ready to roll. All right, so here we go. I was asked on, is it number 7, Cora? Number B?
The one where it has like the less than or equal to signs.
C? Okay, so I'm zooming in on 7C.
Okay, can you explain it to a histogram?
Yeah, so the histogram is supposed to be one of these, except that the data that we have was discrete, and so we're not going to have them touching. We're going to have a gap, so it's going to look like a column graph, not a histogram.
I should show them connected on the answer key, but I tried to circle it.
Well, a histogram does mean that they would be connected, but it said discrete, and when it's discrete, it's not supposed to be connected. So we are not connecting them. Do you have to do what they say? They don't usually have you draw graphs. I've never seen one. But I would do, if it's discrete data, I would separate it, and there's no way they're going to count you wrong for separating if it's discrete data and connecting it if it's continuous. It's the same thing, just they're touching, whereas I'm going to leave a gap.
I was asking you how to do the part.
Okay, so what you do is, once you know the probability for each one, so for this one you had to substitute in 0, substitute in 1, 2, 3, and 4, and find the probability of each one, and then you knew all the probabilities added up to give you 1. So you took all those, added up to give you 1 to get the K. And then go back and put the K in. You'll actually know the probability of each one. And then to do the graph, all you would do,
Is it like based on the probability?
yes,
Okay.
over here would be the probability, just whatever. This is the probability. And this would just be 0, 1, and you just go up however much for each one.
If you say the chance have to do this on a test, and my scale on the y-axis is 16, 15, 12, 7, 0, is that okay?
I mean, I would do it, I would make it proportional if I was doing it on a real test.
Okay, but like right now.
I do not care for right now. The probability that's between 1 and 3, you just add up the probability of 1, 2, and 3. I believe that's the one you were asking me about.
Yeah, so I just add up.
And that's the answer. Okay. Anything else on the book work, since I've got the book open?
Could you show us how to start number 14?
Okay, yeah, some people were asking me about the CDF table on 15, and CDF just means it's cumulative, so if I just put a CDF right below this, I'll just put cumulative, and it's just, consider this a continuation of what you see right there. The cumulative is just adding them up. I don't know, can y'all see those? Well, you're going to have to pretend you do. Maybe if I move it down. Maybe.
They should make this out of less shiny paper. You should work for them, Gabby.
No, it's good.
I think it's just
Perfect, right there. We can kind of see it. Everybody pretend like you can see it.
Hey, there's Seth. Okay, well what you do is, like, the probability of 0 is 0.08, so the probability that you're less than or equal to 0 is, oh dear, Micah, the light went out. Alright, then the probability that you're less than or equal to 1, you just add these two. So, what is that? 0.23. And then the probability that's 2 or less, you add all 3 of these. And so on. Okay, so this is 0.08, this is 0.15, this is 0.22. So the probability that you're less than or equal to 0 is 0.08. Probability that you're less than or equal to 1, you would add these two. It would be that and that. So I'm adding 0.15. Yes. And the probability that you're less than or equal to 2, you add all the ones prior to 2. And you just keep going like that. So that's the CDF. Oh, the light is back on. Cora has the light back on. Then it says calculate the probability that at most 3 lines are in use. So you would just add up 0, 1, 2, and 3. Calculate the probability that a customer calling for service will have a free line. Okay, well, what are these telling us? Defining X as the number of lines in use. Okay, so assuming that there are 6 in use. Okay, so as long as 1 is available, you'll be able to use it. So what's the probability? As long as there's 1 free. So as long as not all 6 are being used. From 0 to 5, or just 1 minus the probability that all 6 are in use. So 0.97. Expected number. Expected number is the same as the average, so you do each value times the probability of getting that value and add them all up. And then standard deviation, you're going to have to use the formula that we had the other day. Don't remember what that is, but you have the variance, and it's like you add up each number minus the average squared times the probability of getting the value. That would give you the variance, and then you take the square root to get the standard deviation. Okay. Anything else in the bookwork? Okay.
My brother's boss is really afraid.
I don't blame you.
And then he found it.
Well, oh dear. Well, the charger's like $10 compared to a $150 calculator.
It's been a rough week.
Yeah, don't turn in the IB packet. So you'll only turn in the bookwork and today's question day, so you can turn in next class if you want. And then hang on to the packet till the very end. But you'll only be able to ask questions on the the question days.
The very end of what?
It'll be next week when we get to the end of the packet.
Just till the very end. Hold on, take to the very end. You're at the IB test.
Any questions on the IB sheet, or are we good on that? Okay. So you'll just be turning in those 2 homework problems from the book and hang on to these IB problems till we finish everything in the packet.
So can I do hand sanitizer and then soap? Or would that be like
Sacrilege.
Probably. No, you can do soap and hand sanitizer.
soap and hand sanitizer?
Soap is superior to hand sanitizer.
Yeah,
Hand sanitizer is what you do when you can't get soap and water.
I do.
Those dead germs just
And
stay
plus,
on
the Germex, like, it stays on your hands and
One time I had
Smells
to go
really
to the bathroom porta potty and there was no sink.
I'm glad that we agree on this terrible warming.
it's terrible. What?
That we agree on the fact that it smells gross when it stays on your hands.
It does. It's very unsatisfying, whereas washing your hands is very
I
satisfying.
don't know. I use it all the time. See, I've always hated salt that stuff.
Not if you yell.
So, we're going to do the binomial probability distribution. When you think of binomial, is there anything that comes to mind?
Pascal's triangle.
2, yes, 2. Actually, Pascal's triangle is a good thing. It is related to the lesson today as well. So maybe when you were thinking binomial theorem, that made you think of Pascal's triangle. And that comes into play today. The binomial distribution does relate directly to the binomial theorem. So binomial probability distributions only work if you're talking about situations where only two different outcomes can happen. Okay, so what I've got is a spinner, and you need to use your imagination because it says it has 3 blue edges and 1 white edge. Okay, so that clearly looks like black and white. I don't know if that looks, there you go, there's blue. Okay, but I didn't print this in blue, so, no, because I've got all the stuff written out on it, so.
You don't want to cheat.
Let's see.
You're a cheater.
No, that's just for me. So, all right, so pretend that these are blue. So you have 3 blue portions and 1 white portion. So if I spin this, I can only get blue or white. That's only 2 outcomes. If I made one that was red, so that there was a choice of spinning and getting red, white, or blue, it would no longer be a binomial distribution. So on the actual exam, I'm going to be teaching you multiple kinds of distributions. They're not necessarily going to tell you what kind of distribution it is. They expect you to recognize it by the fact that there are only 2 outcomes that can happen. The other thing is that each trial has to be independent of the other. So I'm going to kind of go to this for just a second. A binomial experiment is one in which there are only two outcomes, and I'm going to add a little and here. Each trial is independent. So let's say that I had marbles in a bag and they were only red or blue. Well, you'd be like, okay, that's good for a binomial because they're either red or blue. That's only two outcomes that you can have, as long as I say that I'm going to choose with replacement. Because if I take out a red marble and then you're going to draw again for the next trial, it's now dependent because it depends on what I got the first time. Okay, so very important that each trial is independent. Anytime that you have choices without replacement, that means you can't use binomial distribution. Okay, and so just on my little spinner here, what's the probability of landing on, I'm going to stick with blue, pretend it's blue. What's the probability that I'll land on blue? 3 out of 4. What's the probability I'll land on white?
1 out of 4.
Okay, and so there are definitely only two outcomes, blue or white. Each time I spin is independent of the next one. We're going to define P as the probability of a success, and then 1 minus P would be the probability of a failure. I kind of want to look like I'm successful, so I'm going to say that it's a success if I land on blue. Okay, so that has to be defined. Okay, success for this is going to be blue.
So failure for this will be negative 2.
No.
Oh,
1 minus 3/4, so 1/4. Okay, so you do have to define. There's no reason why success couldn't be white, but it has to be defined in the problem, which one you're going to call a success. Okay, so what we're going to do is we're going to make a tree diagram for spinning this 3 times. If we spin it 3 times, I could get a blue either 0, 1, 2, or 3 times. I will say the other thing that can happen with this type of distribution, people forget 0. Okay, so I don't know, we just don't like to think about no success, I guess, but you don't want to leave off 0. So we're going to make a tree diagram. This is the only tree diagram we will ever do for binomial distribution because there is an easier way, but this really, really illustrates how the whole binomial distribution works. So I really do think it's worth it. So Cora, I don't know where you're going to fit it because I have trouble fitting the tree diagram in this spot. So basically you're figuring you have blue and white, and you're doing 3 trials. So off of blue and white, you're going to have blue and white. Off of that, blue and white. Yes, I recommend.
Alright, so blue and white.
Jack's got it, though. He's got plenty of
Can I
room.
make the tree diagram?
No way. I need it to be like super neat, although I am not super neat. I can at least live with my degree of not super neatness. So basically the idea is you got to make 3 trials. That's what you're trying to fit in along each one. Okay. So the first time that you do it, you get blue or white. Same probability along each one.
Now you have to make it similar for each of the whites. Wow. What a tree diagram.
And then the same thing has to be down here. That's where things get tricky. Because I think I'm all good, but then I'm squashed. Yeah,
That's why you just make your like that far apart, just spaced out.
I should have.
The tree is growing in the shadow.
Or you can like extend it way past the other one.
Yeah, I thought I was doing well, but at least I don't think Jack kind of sees where I'm coming from, that this was a, yes. Okay, just to fill you in, normal banter, harassing Jack, fill in the blanks. But Jack, you're not taking notes. I know. Alright, so this is representing for us all the different possibilities that we could have if we did the spinner 3 times. I'm going to list the outcomes over here on the right hand side. So I'm going to follow the path like blue, blue, blue. Blue, blue, white. Blue, white, blue. Oops. Blue, white, white. And then white, blue, blue. white, blue, white, following there, white, white, blue, and white, white, white. Okay, so those are all the different outcomes that could happen to us. And we're defining our discrete value to be the number of blues that we get. So I'm just going to write that over here, how many blues this was equal to. This is going to say variable, not value. X equals the number of blues. Okay, so for this one, how many blues do I have? This one? Okay, so you see that we got 0, 1, 2, or 3 were our choices. And what we're going to do is we're going to find the probability of 0, 1, 2, and 3. Okay, we're going to do that down here.
0 is only 1 out of 8.
Ah, not true, my friend. Okay, so here's 0, but see there's different probabilities along each path. That's why it's not just 1 out of 8. So if you go across this path, it's 1/4 times 1/4 times 1/4. That's the probability that you'll get 0. So I'm just going to put 1/4 cubed.
Which ends up being, what's 4 times 4 times
64. It's 1/64th, but I'm going to leave it because I'm looking for patterns. Okay, now when you look at 1, how many different paths do I have for that?
3.
Alright, so I got this one. Does that even show up?
Yeah.
My orange is dying. It's sad. Okay, I need to go white, blue, white.
364.
And I need to go blue, white, white. They are all the same thing. So I have 3 of the same thing, you're telling me? Okay, and what is it?
364.
Yes.
Well, I want it
3/64.
like in terms of fractions.
3,
They have 1/4, 1/4, and 3/4. So
3 squared. 1/4 times
there you go.
3/4.
1/4 squared and 3/4. Remember I said this was going to relate to the binomial theorem? So I'm trying to look for a pattern. Alright. Alright, so let's do those. Blue, blue, white. Blue, white, blue. And white, blue, blue.
So let's go ahead and try 3, 4.
3 times
3 times, no, 3
3/4
times 1/4
squared.
times 3/4 squared. I was going to order around, but I guess it wasn't. And for the next one, we can already go ahead and assume that it's going to be 3/4 cubed.
That's also right there.
Okay. So if I add up all these probabilities, what should I get?
1.
Yes. So I'm going to write this out. The probability that it's 0 plus the probability that it's 1 plus the probability that you have 2 blues plus the probability you have 3 blues should add up to give you 1. And we'll look at the pattern that we have. 1/4 cubed plus 3 times 1/4 squared times 3/4 plus
That's like the binomial theorem.
you solve
Yeah,
Pascal's triangle right in the beginning.
1, 2, 3, 1.
Plus. Okay, so Jack, I heard you say 1, 3, 3, 1.
Right. That's the only level of Pascal's triangle I know except for 1, 4, 6, 4, 1.
Let's see, what do we see? Okay, so the 1, 3, 3, 1 we recognize from Pascal's triangle. Any other patterns from the binomial theorem? Okay, so you said the 3/4 goes to the 1. You said going up, right? So
Well, like 1/4 cubed, 1/4 squared, 1/4 1, 1/4 0. Let's start 3/4 cubed, 3/4 squared, 3/4 1, 3/4 0.
Okay, now Cora just explained that perfectly, but I was not narrating what Cora was saying. So she said you had the 1/4 cubed, 1/4 squared, 1/4 to the 1, and 1/4 to the 0. So the 1/4 started with the highest power and went down. The 3/4, if you just start at the back end, do the same thing. 3/4 cubed, 3/4 squared, 3/4 to the 1, and 3/4 to the 0. So if I was doing this as a binomial expansion, what would it be the binomial expansion of?
X plus 1/4 squared. X plus 3.
Okay, well there's no x's.
Oh, 1/4 plus 3/4 squared.
Squared.
Cubed.
There you go.
Darn it, I'm so bad at binomials for some reason.
Oh, you're not too bad.
It is?
Well, that's because the other singers were doing binomial theorem. That's why it's on board. Okay, now I also want you to remember that this is the same as combinations. Do you remember what this is the combinations of?
I don't know.
If it's to the third, 3
3 or 0.
3 choose 0.
3 1, 3 2, and 3 3.
Which means that we shouldn't have to draw a tree diagram every time we want to do binomial distribution. We ought to be able to go to just whichever one we want. Okay, so what I'm going to do is I'm going to write out up here just the binomial theorem like it has it on your formula sheet, and kind of show you how we can get to just the right part of it to not have to write it out.
We're on like 22 minutes. Let's see. Let's go to it.
Yeah, that's so long. That is insane. You've been in here for 22 minutes.
Okay, so let's look if we just wanted to get the probability of one particular value. Okay, so let's say that we were trying to find the probability of 2. Okay, so there's the probability of 2. So that's just one particular term in the expansion, and we want to get to the right one. If you remember, this is the general form to find one particular one. Okay, so when we think about that, n, what would n possibly represent for us? 3, and what did 3 represent for us? So n was 3 for us. That was how many times we did what? That's how many trials. Good. So n is the number of trials, which for us in this case was 3. Okay, now if we look at what r is going to need to be in here, if this was the probability of 2, what's r?
The trial you're on.
Yes, the number of successes you want. Okay, and then we need to look, we've got a to the n minus r and b to the r. So if we look at our r was 2 for this particular one because we wanted 2 successes, then that was the 3/4, which was our probability of success. And so our B for this particular scenario needs to be the probability of success, because basically the probability, if you want 2 successes, you have a 3 out of 4 chance out of that, and you want it twice, and you have 1 failure. Okay, so that's what this is representing. It's just there's 3 different ways that can happen. That you have 2 successes, which is why you have the 3/4 squared, and 1 failure. Okay, so this turns into P. This was just to the 1, which was n minus r for us. That's the probability of failure. That's your 1 minus P. Okay, so as nasty as that looks, we're going to write it prettier down here. So for us, this would still be n and r. Okay, and then you would have, looks like that would be 1 minus P to the n minus r, and P to the r. On your formula sheet, and I need to make sure. I believe they do X's instead of R's for you, for your success. So let me just look real quick. Okay, here's your binomial distribution formula. And it looks like what we have basically, but if you look, they're doing just x instead of r. We have r because it comes from the binomial theorem. So how many successes you have as far as on their formula sheet is x. So we're just going to change this to be exactly what they have. So they have x equals x because, oh, I'm not showing. Sorry, it's too big. Okay, so x is the number of successes in this particular situation, and then they just wrote this one first. So you have the number of successes, and then they have 1 minus p to the n minus x. So it exactly matches what we did, except they're just saying n is the number of trials, just like we did, but they're going to say x is the number of successes.
So is the term for the like probabilities how many successes you have always been the second one in the binomial?
Yes, but you mean this.
Like if I were doing if I were just writing it out as binomial with exponent would the second term of binomial always end up being the
Failure?
I was saying success actually, but I feel like probably
It's okay, I'm just not understanding. Here, I'll pause. Okay, so going back to this, now that we have this formula, and it's really kind of logical, this is just the probability of success. So let's say you were spinning something 6 times, and you wanted to succeed probability of succeeding 5 of those times. Then it would be 6 things taken 5 at a time, probability of success 5 times, probability of failure 1 time. Okay, so this is just telling you how many ways you could have that probability happening. Okay, so now I would never do a tree diagram again. This is the only time I'll do a tree diagram for binomial distribution. But let's say, what do you want to do? Probability of, your choices are 0, 1, 2, or 3.
2.
Okay, so if we wanted to do probability of 2 successes, we would say we did 3 trials because we spun 3 times. Okay, and we wanted 2 successes. Probability of success was, and we wanted to succeed twice, and the probability of failure, so 1 minus p, and then this would just be to the 3 minus 2. Okay, and this is just telling you how many ways that could happen. Okay, and you can use the formula for that, you can use your calculator, but we already know that's 3. Okay, so it just became 3 times 3/4 squared times 1/4. Okay, so since we know that if it's binomial, it's going to behave the same way as the binomial theorem, we can just use that formula, and the formula is on your formula sheet. Also, your calculator can figure it out for you. We're going to do it that way too. Okay? All right. Okay. Now, this can also be called a Bernoulli trial. That is another way to call it, besides the binomial experiment. Again, it's something that only 2 things can happen, and they have to be independent trials. And you see that you have all of these formulas on your formula sheet. Notice that these go with binomial distribution. So you're really going to have to be looking on your formula sheet to see what goes with what. Like before we did, this was expected value of a discrete. This was expected value of continuous. We haven't done that yet. We haven't done this regular variance. Variance of a discrete, variance of a continuous. Okay, here's binomial distribution. So if you're doing binomial distribution, you're going to do these 3 formulas. Okay, so you notice there's many formulas for mean, many formulas for variance. You're looking on here for whichever distribution you're doing. Okay, so today we're binomial, and this is the one we just did. This is the mean, so it kind of looks catty-cornered there. This is the variance, and then if you want standard deviation, what are you going to do? That's right, square root of the variance, okay? And this can be done on the calculator. We'll do it on the calculator after we do a couple by hand. All right, so here's a little problem. It says 72% of union members are in, yes? All right, Jack is taking over. He can take my talking no longer.
No, it's
Sorry.
Roger 264. We are inbound on the problem. example number 1. Alright, so we got 72% of...
I'm just gonna go ahead and place the on here. Not the paper way up.
Okay, Cora has requested to move the paper way up. 72% of union members are in favor of a certain change to their conditions of employment. A random sample of 5 members is taken. Find A, the probability that 3 members are in favor of the change in conditions. So we're going to do A first. There we go. Oops, my bad. Wait, what? It's kind of weird to hear it in these things. It's muffled.
One like off my ear, like I'm a DJ, you know?
Yeah. Okay, one's off the ear, guys. So, alright. Let's see here. So you want the probability that 3 members. 5 members is taken. So 5, right? 5 choose 3. Times 0.72.
5 is like the number of trials, and then 3 is like the number that you
Yeah, exactly. Number of successes.
Times, it's 1 minus p.
You just put 1 minus something for your and then you just
Wait, so what would the little p be in this? That's right.
Now you just have to decide what each of those are going to be raised to.
Oh, right. Okay, so, let's think here.
It's raised to the number of successes that you want.
Yeah, so 3,
And then
2.
5 minus the 6.
Yeah, 5 minus 3. So 2. Alright.
And then somebody can magically put that on the calculator.
So she said someone can magically put that on the calculator, but that's going to have to be a Gaddy 10-4 over. Or, no, Dana. It's Dana.
0.29.
0.29?
Yeah, that's good.
0.293 over Roger. Got it.
If you say over Roger, say over, the next person says Roger.
I think you say over Roger, Cora.
Please never go to space.
Okay,
Yeah.
can I go now because I'm going to show them how to do it?
Ms. McCormick is taking over the operation. How copy? Solid copy. Over here, right here, 10-4 Roger Dodger.
Roger Dodger.
Okay, we can also do that on the calculator, but I just want to make sure you see how that relates to the formula. Okay. So I don't know where to write this, but this is the same as the formula that you had up there. So right now I'm very happy that this is understood from a logical standpoint. Just slightly want to make sure that when you have all the distributions together, you know how to go back to your formula sheet. By the way, it is a good thing to tell them that it is a binomial distribution. So see how it says x squiggle b n comma p? What they're saying there is that this is distributed as a binomial distribution. So, and then you have n comma p, where n is your number of trials, which was 5 in Jack's case, and probability of success was 0.72. So actually on these it is good to identify the type of distribution, and this is the first type we've had besides discrete. Binomial has a little squiggle, Poisson has a little squiggle. Okay, and then you just see that Jack did this for n was 5 because that was his number of trials, x was his number of successes, and his probability of success was 0.72. So he substituted everything beautifully. Okay, you can also do this on your calculator, which is most likely where you'll be tested, but they do occasionally put it on paper 1. But usually this is done on paper 2. Okay, so go to a calculator page, and if you have the printed out notes, it actually gives you the directions on the next page of the printed out notes. So you can turn to it. It says binomial distribution on the calculator. Okay, and so you're going to choose menu. Now, it's under both probability and statistics. So if you look under probability, you'll see distributions. And then also, if you look under statistics, you will see distributions. It is two ways to get to the same thing, but just for consistency, because I think of it as a probability distribution, every time when I go to it, I'm going to go probability distributions. Okay, again, you can also get to it under statistics. Okay, and so what you're going to do, you see there's different ones, normal PDF, normal CDF, all this stuff. You're going to keep looking until you see one that is binomial. So down there on D, there is a binomial PDF and a binomial CDF. If you will, make sure you get a calculator. I will pause for a minute to make sure each person has a calculator and is touching said calculator.
Wow.
Okay, so again, you're going to a calculator page. You're hitting menu, probability, distributions, and then you're looking to where you have a binomial PDF. Okay, is that a different letter for some of you?
Yeah, I have A.
Okay, that's really weird. Okay, just go to whichever one says binomial PDF. Okay, well then there's obviously a difference in the versions, and I'm about to have to update everybody's everything. So it has to be updated for the IB exam. So number of trials for the one Jack just did, we had 5. The probability of success was 0.72. Now notice it says optional here for the X value. The X value is the number of successes. I'm going to show you what happens if you put something in and what happens if you don't. So we're going to put in for now 3 because that was how many successes Jack had. Okay, and there you see it did it for you. Okay. Now, let's do the same thing. It said it was optional. Let's go through and not put it. Probability, distributions, and go to your binomial PDF and put in the same thing, 5.72. It claimed this was optional, so I'm not going to put anything. It's giving me a lot of answers. Okay, here's what it's giving me. It's the probability of 0 successes, 1 success, 2 successes. Look, there's your 3. And then if you go up and scroll over, there's a probability of 4 successes and the probability of 5 successes. So it lists out all of them for you, 0, 1, 2, 3, 4, and 5. Okay? So that's somewhat useful because if you look, the very next question on ours is asking you for more than 1. There is another separate thing for that. You're right. Okay, so let's take a look at what it asks next. The probability that at least 3 members are in favor of the change conditions. Now, here's why it's important, because you don't have to show much work because the calculator does everything for you. By the way, I also think Megan might be getting tired over there.
I can't see it.
Okay.
I fell asleep during my history presentation. I did.
I feel slightly less insulted now. Okay, it's important that you put this to get the marks that it's a binomial distribution, because the probability that at least 3 members, all you have to, I would go ahead and say the probability, if it's at least 3, then it's going to be between 3 and 5. Because all you're going to have to do is do it on the calculator. Now, if you had to do it by hand, you would add up the probability for 3. You'd have to do this for 3, and then for 4, and then for 5, and add them all up. But if you go on your calculator, you can go to the CDF, and that's just cumulative. So menu, probability, distributions, and you just go to whichever one for you is called a binomial CDF. Okay, so pick binomial CDF. We've got more choices now here. Number of trials was 5. Probability of success, 7.2. Lower bound, upper bound. And I apparently escaped out of it or something. I know, wasn't that sad? I don't know how I managed that. Okay, there we go. 0.862, by the way, 3 sig figs is your running favorite. You wouldn't say anything was your favorite. All right, if you take a look at this one, it says the expected number of members in the sample that are in favor of the change. Okay, we'll go back up here. This is expected number, or mean. They can call it either one. It's just N times P. What is N? What is P?
3.6 people.
Okay. So about 3.6 people. We could have done that before, right? We didn't really do anything to do particularly with binomial distribution. That's the same way as we figured out expected value before.
Wait, do you not have to like round or anything? You can't have.
I do understand you can't have 3.6 people. So I am going to put 3.6. I would more likely expect 3, but yes.
So, technically, to find that C part out, you could have just done from 3, 5 choose 3 times 0.72 to the third, 1 minus 0.72, 5 minus 3, plus, and then do it with like 4 and then 5 successes. You know what I'm saying?
For this one,
Yeah.
yes. I thought you were talking about this one because you said expected value. Yes. Okay, I'm going to give you a D. We're going to find the variance. Okay, so the variance formula for binomial is NP times 1 minus P. I've already done NP. Trinity, Cora has you on the moving the paper up.
What? No, Cora is bullying me.
Apparently there's some bullying going on.
1.008.
That's what this is. Okay, and what if they asked you for the standard deviation? Square root of that bad boy, I have been told.
1.004.
SD, like standard deviation. What?
That would have been too easy, Dana. Just tell Trinity that I'm taking pictures of the notes to send to her so she knows how to write them.
Okay, Trinity, Cora's taking pictures of the notes so you know how to write them. Alright, here we go. On this page, by the way, you've almost made it. We're almost done.
Wait, what did you say?
I said we're almost done. Okay. Alright, so all of this is just the calculator directions in case you forget. Alright, so here we go. Jack, I think you got this.
No, Megan wants to do it. Never mind. Megan's not going to do it.
Realize that.
I mean, you can tag team.
Oh my gosh.
Hey, y'all gonna have to help silently.
I think that's his favorite part.
Roger Dodger. Falcon Dowling X3 is back.
This class for 42 minutes. That's crazy.
Cora is currently making fun of me.
43 now.
Wow. So,
Such a little-
let's read the problem. I'm going to scoot it up because I've learned that you need to do that in this class a lot. Where's the extra paper? Because I feel
Underneath somewhere.
underneath there.
Just go way down the bottom.
You never know, Ms. McCormick, with these types of things. Okay, anyway.
Because you're going to go pretty much calculating this.
Pretty much calculated.
Just start reading.
I like it. Anyway, at a manufacturing plant, 35% of the employees work night shift. If 7 employees were selected at random, find the probability that A, exactly 3 of them work night shift.
Jack, when you start with the X squiggle B,
X, yes.
because that gives you ID points.
B,
B.
I heard
binomial.
D. Oh, sorry.
And then in parentheses, N, comma, P, only put your N and your P.
Okay.
Because there's very little work, so you're telling them that you've identified this as binomial.
Wait, so it would be
7 and
7.
Right, which is why you have to tell them something. What you're doing in the calculator.
Okay.
You didn't just look on
Good job,
the
Josh.
sheet. You
Thank you.
knew what you were doing yourself.
Alright, so then, excuse me, so, exactly 3 of them work night shift. Man, this is kind of weird, sorry. Huh?
There's no question marks.
No?
X squiggle B, 7, comma, 0.35. This is N and this P.
Yeah, I got you.
Okay. When you do 7, choose 3.
Okay.
Is that wrong?
It's right.
You can
Okay.
do the count though.
That's not what you
0.268 is my answer.
They did it in the calc. They don't want to do it by hand. I don't know why. It's just not fun. But what's the answer, Nick?
I don't know if it's right, but I have 0.268.
That's what I got.
Okay, but you need to write probability that x equals 3.
Okay, sorry, 1 second. Wait, sorry.
You can put it is 0.268. So as far as work that you have to show, put probability of x equals 3 equals 0.268. So if you show those two things, it's enough work. Can you show how to get that on the calculator? So that
You want me to show it? Okay, where's the
Just click down
calculator?
there on the thing with the apple.
Okay.
No, that's
That's recorded. That's not an apple. My bad, guys. I'm embarrassing myself a lot today.
Dana just bullied you.
Why?
She pulled a straight set. I
Yeah.
didn't say it.
Oh, yeah, Sam. He's a guy I know.
Me and Jack have mutual friends.
No.
Apparently Sam's a bully. I don't really know him. I think I was bullied with him once, honestly.
Oh, I did it twice? Just to confirm. Double. Right there. Okay, so then. What?
Go on, Jack.
B.
B. We're going to move a lot faster now. Less than 4 of them work night shift.
so it's less than 4. It's between what and what?
0 and 3.
0 and 3. So you need to write probability.
Yep.
0 is less than equal to x is less than equal to 3. And highly emphasize the 0 to them because people leave out 0 a lot. They'll go like 1 to 3.
Please yell 0 just randomly, Jack.
Probably. 0 x to 3.
I'm sure he's okay. One time I coughed and scared her just imagine until I screaming at her.
Slide on the CDF.
Right.
It's the same thing you did before.
I don't know. This is kind of. It's kind of weird on the computer
So even
because
with
it's
the
not
bound,
like clicking.
is the number of trials still considered 7?
Yes.
You did something.
Yeah.
Thank you. I know that's not true, but that's okay.
I'm sure they'll be weirded out about it.
Why does it do double?
I don't know. But it's better than me when it didn't work at all.
Yeah. Okay. Anyway, C. It's 0.80.
Click on Ladybug.
Yep. Heart C, people.
Jack.
Darn.
You did click on it. It just didn't. Go ahead and put that equals 0.800.
Okay.
C. One more.
C. This one's gonna be quick. Less than. Wait, no. At least 4 of them work night shift. So your lower bound is gonna be 4 to 7.
If you do 1 minus 0.8.
You could do 1 minus 0.8.
It's very smart.
You could do that, but that's not fun. So, what we're going to do.
Wait, no, you gotta have the probabilities to be. Probability.
Gotta go back to the ladybug, guys. Probability of 4 to x, or is less than or equal to x. Right, I let the correct.
He's trying to get you.
Alright. It's gotta be grease lightning. Alright, we're gonna move fast.
That was not the right lightning reference.
I don't care. Hold on.
Jack, say ciao.
Ciao. This is gonna be good.
I'm using the name next time.
Yeah.
You know, that's the whole commercial where Alexa listens to her voice.
I love that.
Yeah,
That commercial
Every
was
time I
hilarious.
try to watch a YouTube video, I see that commercial.
But that would be Jack. Imagine if he was Alexa.
My favorite part of that was when Gordon
That's
was
it.
like, what
And
do you
point
mean?
out-
You could put
Yeah, I will.
Oh my gosh, the instructions are
So when you do it in the calculator, oh, let me pull it back on Ladybug. When you do it on calculator, you get like 0.19 or something.
199.
9.
1.1998446.
So it rounds up to 4.
Cora, that does not round up to 4. Thank you very much. if you do 1 minus 0.800, that's going to equal about 0.2, which this rounds up. Oh crap, guys!
Comedic relief.
Approximately 0.20. Y'all ready for this? Those are waves, by the way. Y'all ready? Gaddy's clapping. This is the eagle flying out of the nest for the very last time. Roger Dodger, copy over. No problem.
No problem.
Alright, last thing is just a picture.
Oh, that's a nice picture.
And here's the same picture in color. Okay, so if you look, this is just a picture of the binomial distribution, just to get you a picture of it, kind of a visual for it. So the blue one, which is this first one, has a probability of 0.5 and a number of trials of 20. So if you just look at the blue one, you notice it only goes out to 20. Okay, since the probability is 0.5, you would expect the highest to be right 0.5 times 20, 10. Okay, that's the highest probability that's going to happen. It's your highest expected value, and it's symmetrical on each side. Okay, so your probability of having n trials, yeah, it looks like that, is highest at 10, and it goes out. Now, if you compare this, let's compare it to the red one. Okay, that's also perfectly divided. It had 40 trials, so this does keep going out to 40. Okay, it's centered, as you would expect, at 20. Okay, but if you look at this one, the probability of success is 0.7, a much higher success rate. This is skewed left because the tail is longer on the left, and the highest point is 0.7 times 20. It's right about 0.14. Okay, so when you do this, the highest peak is at your expected value. Okay, and then your homework is the binomial in your packet, and so there are 8 problems to do. Okay, and as you would expect from HL problems, they will do twists on it where you're solving for something weird. I'd like to point out that on a couple of them, when you set it up, you have to solve it by trial and error. And hang on just a second, I'll take.
Make it louder, like put it right on top of
That's a nice one.
Best thing happened to me. This song says, when it stopped, I changed the channel,
Music
and it was
brought
playing
to
on the other one
by-
too.
This is brought to you by Jack. This McCormick has a quick announcement, and then I'll be back with my annual podcast.
Annual broadcast?
Annual podcast.
Podcasting, get it right. Just on number 7, I want to alert you to the fact that when you set it up on number 7, you will be solving by trial and error when you get to the B part. Okay, you'll be trying different values. Okay, you may use the calculator anytime that you can. Yes, you're doing 1 through 7 in the homework. No, 1 through 8 in the homework packets. Okay. Anything else, Jack? Signing off here.
I can talk a little bit.
Okay.
Hey guys, so the lesson is over. You can end the video right here at 54:25, but you know, life lessons are always important too. So, what we're gonna do a little bit of today. If y'all have any questions, just please call in at extension 243 or whatever it is, and I'll be here taking questions. Any questions from the, as Michael would refer to it as, the shout out, Michael, you're welcome. The peanut gallery. Any questions?
Tell Michael I missed him.
Carla, calling in from Sigmont, Tennessee. What's that, Carla?
Do I have to say it again?
Yes.
Yeah, you're breaking up a little
Okay,
bit.
well, I miss Michael.
Well, Carla says she misses Michael.
Yeah.
That's a nice little thought.
I don't tell Michael my class is really quiet.
Just because I made a Vine joke and I just felt like it was not as appreciated.
Yeah,
Carla made a Vine joke,
But
and it
sometimes
felt
when Michael laughs, it
underappreciated.
means a lot
It
to
felt
me.
empty. Yeet.
Jack, what makes it? Does Jack, do you get bullied by people?
Yeah, Cora asks, Jack, do you get bullied by people? We want to first thank you, Cora, for calling in. Again, from Sigmont, Tennessee. Must be a popular area today. So, do I get bullied by people? Well, it depends on what you would call bullying. Because, you know, I'm not getting shoved into lockers each day, you know. I mean, there are people who face it worse, but what I'd say is when I'm doing a problem with math, now, I know what y'all are thinking, man, why is this guy in math is like 35? And I'm like, no, I'm actually still 17.
Hey Jack, tell Jack he has way too many
Oh, we're
tabs
getting
open.
an opposing caller. Never mind. Anyway, back to the bullying question, and then we'll be done with the podcast. I'm just getting bullied by Dana right now. She is fixing my sweatshirt. Anyway, Cora, to answer your question about bullying, it's a struggle when you're up doing math problem, and it just happens that people are like, Jack, you did this wrong, Jack. I'm like, I know. Just let me do it my way. I know. You gotta. Sorry, I got.
No, Jack, it's going to be a radio DJ.
I got heated there for a second, but not on the quiet channel. So, to answer your question, do I get bullied? It's not really black and white, but it's a good question. So thank you. This has been my yearly broadcast, the podcast. And as I will close it today, Roger Dodger, copy, solid copy, over, out, whatever you want, Roger Dodger. I will see you. All I need to know about life, I learned from Star Trek. Thank you very much. Goodbye.